All right, boys and girls, here we are ready for another exciting video. We are going to talk about volume. This is the second video in our series on mass and volume. So today our I can statement says, I can precisely calculate volume using the correct unit. So we're going to talk a lot about the word precisely. That just means that I can do it to the best of my ability, that I'm very close and accurate when I'm calculating volume. Hope you have your paper and pencil and you're ready to get started with me. Today there's not going to be a whole lot of calculating, doing math problems, but you're going to draw some pictures and we're going to learn about the tools and the units that we use when we calculate volume. Okay, so we have two big questions that we need to answer before we get started. The first one is, what is volume? Volume is how much space an object takes up. And we could be talking about how much space does a solid take up, or we could be talking about how much space does a liquid occupy. If you have a glass of milk in the morning and we talk about the amount of milk you have, that could be considered volume. If we talk about how much space your couch takes up, that could be considered volume. This would probably be important information for the summary part of your WSQ. Our next important question is, what is capacity? So capacity talks about how much a container can hold. So if we talk about what is the capacity of your bathtub, well, it's only can hold so much before it overflows. What is the capacity of your swimming pool or the capacity of your glass? Containers can only hold a certain amount, and that is what the word capacity means. Okay, the next thing we need to talk about is what tools you would use if you were going to measure volume. So I've got two different tools up here. I wonder if you know what either of them are called. This one is just a larger version of this. You might even have one at home that looks similar to this. I bet you have some type of measuring cup. If you have a liquid measuring cup, it might even have markings on the side like this. Scientists and mathematicians use this, and it's called a beaker. So it looks like a large measuring cup. It has markings on the side that indicate how much liquid is inside. The other tool is over here. It looks similar to the beaker. It's tall and skinny. It has what appears to look like a ruler on the side if you look closely. Sorry, my dogs are arguing next to me. Ignore. The ruler on the side of this tool would help indicate how much liquid is inside. You'll notice that it also has these handy dandy slider gadgets, for lack of a better term, that you could slide down to assist you in measuring the liquid that's inside. So I bet you're wondering, what's the name of this tool, Mrs. Young? Well, let me tell you, it is called a graduated cylinder. So just like when you finish high school, you graduate, this is called a graduated cylinder. It has that name because graduated can mean to gradually increase, and so you'll see that the measurements on the side of the container increase. So it was called a graduated cylinder. Can you say that with me? Graduated cylinder. If I were you, I would want to make sure that I have the names of the tools written down on my paper. Okay, there's another important thing you need to know about using the graduated cylinder. So I've got this wacky illustration here. you'll notice that the center is our graduated cylinder. So this here is to represent the graduated cylinder. If you're looking at a graduated cylinder, you'll notice that the water, or liquid, doesn't have to be water, seems to cling to the edges of the graduated cylinder. And there are a couple rules to using a graduated cylinder. One is that you have to read it at eye level. So if you're standing above it, if your eye's up here and you're looking down, you can misread the graduated cylinder as actually lower than it really is. Or if you are lower than the graduated cylinder and you're looking up at it, you could misread it and say that it is higher than it is. So you have to get your eye even with the level of the graduated cylinder. And then this curved part has a fancy name. It's called the meniscus. Can you say that with me? The meniscus. And so you have to make sure that you read the graduated cylinder at the lowest level, or the meniscus. So you want to make sure those two rules again. I'd probably write those down. You want to read it at eye level. You don't want to be higher or lower than the liquid level, and you want to make sure you read it at the lowest point, or the meniscus. Okay, the last important thing you need to know is what unit do we measure these in. So I've put another graduated cylinder up here. You can see that you can see the ruler on the side, and if you notice up in the corner here, it says ML. I wonder if you have any idea what the unit is. Well, the main unit is the liter. And I bet you've heard that word before. If you buy soda, it comes in a 2-liter bottle. And so you've probably heard that word before. So the main unit is the liter. And then if we want to go smaller than that, it would be the milliliter. Man, that's a lot of L's and I's in there. The milliliter. Now, you'll need to know what the abbreviations are for those. So the liter is the capital L, and the milliliter is a little m and a capital. For our school purposes, we're going to stick with liters and milliliters. Most of the time, though, we'll be measuring in milliliters. And you'll notice that all of the tools that I showed you, those typically would hold liquids. So you can think of liters and liquids. So most of the time we're going to measure liquids with liters. So those kind of go hand in hand and help you remember that the unit for measuring volume is liters. Okay, at the beginning of the video, you heard me say that volume is how much space an object takes up. But we've only really been talking about liquids. So what about solids? If I want to know the volume of a solid, and I want to know how much space an object takes up, and I'm talking about, not just the floor, the area it covers, but how much space it takes up inside of it. What does liters and liquids have to do with that? Well, I'm glad you asked. Let me tell you. If I wanted to measure a solid, so let's pretend that I had a ball and I'm just going to sketch it. So I would first fill my beaker or my graduated cylinder with liquid. So this one is measuring at 300 milliliters. Whatever I want, whatever solid object I want to use, I put inside the beaker and it goes to the bottom. And when it does that, the liquid and the ball can't take up the same space at the same time. So the ball takes up the space that the liquid is in, the liquid is in. And so that raises the level of the liquid. So if I want to know how much space the ball is taking up, I would say that it started at 300. That would be my first measurement. And then I would take the second measurement and I would subtract those two. And then the difference would be how much volume the ball takes up. So that's kind of a little bit advanced, but this property is called displacement because we are displacing the water in order to figure out how much volume the object takes up. So that's how solids come into play with volume. Okay, we're almost done. I've got a couple problems for you to work. So read this one, work it carefully, pause the video, and come back to check. Okay, let's work through it. So she had 46 milliliters of orange juice and 37 milliliters of milk for breakfast. On both Monday and Tuesday, how many milliliters did she have in all, more or less? So since it was only 2 days, I chose to add, and you can see my work there. You could have also, what other way could we have done it? You could have also multiplied. So you could have done 46 times 2 and 37 times 2 and then added those together. Could have distributed or used the algorithm, either one. So I hope you got 166 milliliters as your total. Okay, last problem. Go ahead and read this one and solve it. Pause the video, no cheating, and then come back to check. Okay, so let's look at this problem. It says James needs to fill his swimming pool. His pool will hold 5,042 liters. If his pool has 2,589 liters in it now, how many more liters does he need to add? So there's your clue, how many more. That tells you it's subtraction. And I've set my subtraction up. Remember when you go next door here and there isn't anything there, you had to jump over here to the thousands. It becomes a 10 and then a 9. And then you just subtract like normal. And I've used liters as my label. So we've come to the end. Good job. You now know everything there is to know about liters. So I think it's time for our joke. Okay, we've reached the end. It's time for the joke of the video. What do you call, or I'm sorry, what is black and white and 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 black and white? It's a penguin falling down the stairs. See you in class.